So hi, today we are here for discussing about some topics that is about my syllabus, computer networking, and we will discuss some topics about that. I'm doing this practice because I can best prepare for my examination, and I know, of course, this will help me. So I am using here my notes so that I can read all the written short notes and I can easily get in my mind. Okay, and as well as I can improve also my English and my it can also help to improve my channel reach. Okay, that's so first we will discuss about OSI model. That's a full form is open system interconnection. OSI model is like a map or step by step system that explain how data travel from one computer to another. Okay, OSI model is like a map or a step by step system that explain how data travel from one computer to another. Okay, why why OSI model is important? Help us to understand networking clearly. OSI model help us to understand networking clearly. Used to design, learn, and troubleshoot network. You know, we use OSI model because we can design, learn, and troubleshoot networks. Okay, and every layer has fixed job. As we know in OSI layers, we have seven layers. So don't do. So we have so every layer have a fixed jobs. Okay, like yeah, I'm going to talk about all of the layers. So first layer is application layer, presentation layer, session layer, transportation layer, network layer, data communication, data link layer, and physical layer. Okay, more or less. So here we will discuss layer by layer. So first layer is physical layer. Sends raw bits 0 and 1. Physical layer is used to send raw bit data. Like a 0 and 1 in the form of 0 and 1 deals with wires cable signals. Physical layer it indicate us to about physical things like deals with wire cable and signals. So it's all things are physicals. Okay, electric signal moving through LAN cable. So uh, electric signal moving through LAN cable. Okay. Physical layer is responsible for transmission of raw data bits over a physical medium. As I said, so as I was said, physical layer is responsible for transmission of raw data bits over a physical medium. Okay, and we will move next. On next is layer two data link layer. So it will help us to in error detection, and if we are detecting the error, they use make address and makes your data goes to correct device in local network. Uh, it's a data link layer makes your data goes in correct device in local network, whatever we network form in our local systems. Example, like when we send the data in computer lab, that we can get example. Okay, data link layer provide node to node delivery and error detection. Data link layer provide us node to node delivery and error detection. Okay, here we will move on layer 3, that is network layer. So find best network layer helps us to find best path. It uses IP address, routing happens here. So routing happens in the network layer. Okay. Example, like a computer map finding routes. Sorry. Google Map finding routes. In Google Maps, we find routes. So they used to take help of network layer. uh, Here I wanted to give a disclaimer, like it can be I'm wrong here, but I'm doing this only for me. And if you would like to watch, you can watch. If you not, that's no problem. So network layer is a responsible for routing and logical addressing. That's a simple definition of network layer. What network layer is responsible for routing and logical addressing. Okay, it is responsible for routing and logical addressing. Two things. That's only two things. Okay. So here we will move on layer four. That is transport layer. That is the middle layer. Like top of the layer we said the software. I think software layer, and bottom of the layer we said the hardware layer. I think. Because it is divided, and that's the layer come of on the fourth layer, that is transport layer, and is a middle layer, we can say. Control data flow. Transport layer helps to control data flow, breaks data into segments, ensure ensure complete delivery. Ensure complete delivery. Control data flow, breaks data into segments, ensure complete delivery. Like transport layer help us to ensure our delivery is proper and just going complete. Okay. Like if you are getting example, so that's courier service checking all parallel or parcel reach, like whatever parcel reach in a couriers, so they check all the parcels. Okay. So if we use a definition of transport layer ensure equal data transfer between sender and receiver. So that's the definition of transport layer. What transport layer ensure reliable data transfer between sender and receiver. That's the things. So here we are moving on layer fifth. There is a session layer. So a starts, manage, and end communication session. We can say session layer. When we build the website, so there we heard about a topic that is session. So I think it's a very connected of that topic. Like start, manages, and end communication session. Like login, work, log out. Like we log in on a website and there we done works, and then what, log out. That's simple. As like this, session layer establish, manage, and terminate session. Session layer, what session layer? Session layer establish, manage, and terminate session. That's the thing about session layer. Okay. Here we have the sixth layer, that is presentation layer. Like in the presentation layer, we can get idea by using presentation word. Like in this presentation where presentation layer data formatting, we format the datas, and encryption and decryption and comparison with the sender's data and receiver's data, so that we can match all the details are same or not. Like example, converting language before sending message. Like if you are communicating with that people, they are not actually able to understand my language, they have other language, so first we need to translate them and then send him. Okay. Presentation layer translate data into a reliable format. Presentation sorry, yeah. Presentation layer help us to translate data into a reliable format. Okay. And now we have the final layer, that is application layer. It's also seventh layer. So like application layer we use direct interaction with users. When we need to direct interactions with the users, we use the what? Application layer. Provide network services. Example, browser, email, WhatsApp. Application layer provides services directly to the user. Like application layers provide services directly to the users. That's the final definition of the application layer. It's all definition are short definition. I'm written this definition so that I can read at the time of examination, and this takes less time so that I can remember at least something. So now we will go ahead on the second topic, that is TCP/IP model. This is exactly similar like OSI model, but some difference. TCP/IP model is a real internet communication, you can say, model. It used in real life, and when we talk about OSI model, it is for the understandability, like how the people can understand, so that we are make a seventh layer of model. That's because okay. So here we will move on TCP/IP model, and first we will discuss about the TCP/IP model definition. So TCP/IP model is a practical model used in real internet communication. Hmm. It's a practical model. Actually, TCP/IP model is. Look at this, my notes. Used in real internet communication. If OSI is a theory map, TCP/IP is the real road used by the internet. If OSI is a theory map, TCP/IP is the real road used by the internet. Means it's a real road, you know. It's a dream and it's a reality. It's a lots difference. Internet, email, website, all work on TCP/IP. Hmm. Whatever we use the internet services, email services, and any websites, all work on TCP/IP. Why TCP/IP is important? Why TCP/IP is important? This question is very valid question, and we should question if you want to know. I think it's going to banging on that. Okay. Okay. It is actual model used on the internet, simpler than OSI. Actually, it's an actual model used on the internet, simpler than OSI. OSI is mainly for learning. TCP/IP is for implementation. We use OSI model for learning, and TCP/IP model we use for implementation. So we can implement. So TCP/IP model is a protocol-based model used for real-world network communication. That's the exact definition of the TCP/IP that I have written in my copy. Okay, notebook. TCP/IP model is a protocol-based model used for real-world network communication. Got it? TCP/IP model. TCP/IP is a protocol-based model. Okay, TCP/IP is a protocol-based model used for real-world network communication. That's okay. So here we will talk about the numbers of layer in TCP/IP. So we have four layers in TCP/IP. First, application layer. Application layer. So application plus presentation plus session, if we will relate with the OSI model. So in the application layer of TCP/IP, going three layers of OSI model. Like first application layer, presentation layer, session layer is in the single one layer, that is application layer. Okay, and second layer is transport layer. So transport is matched by transport layer. Okay, that's quite similar. And third is internet layer. Internet layer is related by network layer, that is based in OSI model. Network access, data link plus physical layer. So we have four types of TCP/IP layers. First is application layer, transport layer, internet layer, and network access layer. That's okay. That's enough. Move. So here we will discuss one by one. Okay, that's cool. Layer wise explanation. First, application layer provide services to users. Combine three OSI layer. That's 2 point is enough for this application layer in TCP/IP model. First, provide services to users. Second, combine three layers OSI. Combine three OSI layers. That's enough. I don't know. We need more. Example: HTTP, FTP, FTP, SMTP, browser, email. It's all the example of application layer TCP/IP model. That's a final definition. Here we have application layer provide network services to the users. Hmm. Applications layer provides network services to the users. That's a final definition. That's a quite easy, you know. Application layer provides what? Network services to the user. Network services to the user. Which one is provided? Application layer. That's simple. So second one is transport layer. Transport layer is used to end-to-end communication, error control, and flow control. Use transport layer for end-to-end communication, and second point is error control and flow control. It is also used to error control and flow control. Okay, important protocols. First, TCP, reliable. UDP, fast but unreliable. That is used in transport layer. Okay, so here we will discuss the main definition. Transport layer ensure end-to-end delivery of data. That's a only one line definition. We have to understand, actually we don't need to remember. If we will understand, we will write an examination and get a full marks. That's a transport layer ensure end-to-end delivery of data. That's okay. And here we have the third model, third, sorry, protocol. Layer. Actually, layer. It's not a model, it's not a protocol, it's a layer. Internet layer. And internet layer is used to routing and logical addressing. Logical addressing is happening by using IP addresses. Okay. Example: find best path across network. It is used to find best path, like west route. Which route is shorter? Which routes have not traffics? That's the route that helps to find which layer. Internet layer. Internet layer is responsible for routing and IP addressing. Internet layer is Internet layer is responsible for routing and IP addressing. Okay, so here we will move on. Network access layer. That's the final layer or last layer. Okay, network access layer. Physical transmission, MAC addressing, hardware related work. Each and everything is going in network access layer. Like three things: physical transmission, MAC addressing, hardware related work. That's three things is going in network access layer. Okay. Example: Ethernet, and Wi-Fi. Network access layer handles physical transmission of data. That's the final explanation or final definition of the network access layer. Network access layer handle physical transmission of data. It means as we are able to use network layer in OSI by using two layers, physical layers and data links layer. So data links layer or physical layer is combined in our TCP IP TCP IP model, and that is called network access layer. That's okay. Network access layer handles physical transmission of data. That's simple. So now we have a point, that is fifth point, and here we will compare the OSI model and TCP IP model, and just check out some one two differences between them. Like OSI model have a seven layers, and TCP IP model have a four layer. So that's a that's a difference, you know. Like OSI model is a theory model, and TCP IP model is a practical model. That's also a difference. Like OSI model is used for learning, and TCP IP used on internet. That's a difference, and we can make a hundreds of difference between OSI models and TCP IP model. So this is the time of talking about network topology that I have write down today in my notebook by using Chat GPT, and it's a proper Chat GPT, and that I am revisioning here so that I can get in my mind. And after 10 days, when I'm going for exam, when I will go for examination, I can write something just for that, and I can also understand about networking, how it's work, and how can I better use in my upcoming technology that I learn. Okay, I know 100% help me, because if I'm more focusing on networking. Networking is the best part of internet. Whatever we are doing in our internet, networking is most useful and most helpful for us. Okay, no problem. Network topology. So, what is network topology, by the way? So, network topology means the shape or a structure in which computers are connected in a network. What? Network topology means the shape or a structure. The shape or a structure. What? The shape or a structure. The shape or a structure in which computers are connected in a network. In which computers are connected in a network. That's it. Network topology means shape or structure. No, nothing. Shape or structure. Okay, in which computers are connected in a network. In which computers are connected in a network. It's okay. Network topology refers to the physical or logical arrangement of nodes in a network. Network topology refers to the what? Physical or logical arrangement. Physical or logical arrangement of node in a network. Yeah. Node in a network. Actually, my throat is going dry. I don't know why. Because I have not a practice of speaking continuously in a louder voice. I think that's a problem, and I'll fix it. And it will fix automatic when I will create everyday videos, and when I speak in louder voice, that will fix it. I think. Okay. तुझसे दूर कहीं गुजर के सकता है. Okay. Oh yeah, move. Network topology refers to the physical or logical arrangement of node in a computer. That's okay. That's setup. That's a start. So here we will discuss four types of network topology, and I know we have so many types of network topology, but here we are discussing very less. That's only four, because I know when I have to write an examination, that's four is literally enough, and that's four topology is helps me to written in 4 pages, and it will cover 4 pages, and that's enough. I know. I'm also understand. I'm also trying to learn these all the things. That's okay, no problem. But there's a main thing is helps in my examination, covering my 4 page of exam set, answer set. That's the main point. Sorry, I'm joking. Just I'm joking. Okay. So here we are discussing about four network topology. First bus, second star, third ring, and fourth mesh topology. I know we have tree topology and hybrid topology and more topology, but we will not discuss all of the topology. We will discuss just about four. Okay, so bus topology. Okay, all computers connected to one single cable. So in the topology, all computers connected in one single cable, just in a single cable, just like our backbone. It's a single backbone, and when we go to look at them, and our it's a backbone, and here. Some parts is come from our backbone, and that helps to make a nice. I don't know how can I explain it. But okay. And as like if we will imagine a bus, like let's say it's a bus, and it's a way of going, like you are going from this side, okay, like that, okay. And you can see this side is seat and this side is seats, but the direction for going is it's a way of direction is going, and left side is a seat and right side is the seat, and that's like exactly same used in a bunch topology. That's the it's our main wire, and both sides have a computer that will connect with this single wire. So when we use bunch topology, we have some advantages or disadvantages. Both exist same time in bus topology. Like first we will discuss about bus topology definition. So like all computers connected to one single cable. That's the simple definition that we can also elaborate. But here we will not, like if we will talk about the advantages of bus topology. That is very cheap. We don't need to purchase a big length of wire cable.
Okay, so finally now I have connected with my live stream, and I was disconnected because of some network issues, but that's resolved right now. So, so we are on the disadvantage of network topologies. Sorry, bus topology. Okay, and as we listen, as we understand, like first main cable fail, entire network fails. Okay, second point, not good for large network. It's not good for large network because when we work on the large network, there will if there will network will fail, that can be a big problem. Okay, in bus topology, all devices are connected to a single communication line. In bus topology, all devices are connected to a single communication line, as we say. Actually, I want to share something about me. Like when I'm here, I'm creating videos, so I'm facing some issues about this. Here you can understand on my face when, if you are able to understand the body language, like you can decode my body language, you can easily see what I am facing here. That's no problem. That's no problem. That's time that is going with me, and after this time, it will 100% fix. I know. So, okay, no problem. Move on. Like in burst topology, all devices are connected to a single communication line. And second is the star topology. All computer connected to a central device like hub or switches. In the star topology, all computers are connected to a central device, hub or switch. And its advantage is easy to troubleshoot. If any problem will occur in the computer, this will help to easily troubleshoot the problem. Okay, if one cable fail, network still work. It's not like burst topology. It's a different, when one cable fails, network still works. And disadvantages: if hub fail, whole network fail. When hub will going destroy or fail, and if any issues comes in hub, that's your network will be destroyed, and a single device will not work in network. So more cable required, and one more things, star topology need more cable, and it will more expensive than bus topology. That's simple. That's two disadvantage we have discussed here. So in a star topology, each node is connected to a central device. Hmm. That's the main thing about a star topology, because in the star topology, each node connected into a central device that is called switch or hub. Hmm. Third is ring topology. Each computer connected in a circle. In the ring topology, we can, when we spoke ring, we can imagine a ring, and you have to set all the computer in a ring. Okay, in a circle, I think. So each computer connected in a circle. Each computer connected in a circle. Its advantage: equal access for all nodes. Equal access for all nodes. No data what collisions. No data collisions. Like data will not collision in each other. Disadvantages: if one node fail, network breaks. Disadvantage of ring topology is if one node fail, network breaks, because they are in the circle, and if circle will break, every network will be break. Mm, okay. Difficult to maintain. In ring topology, each device is connected to exactly two other devices. Yeah. In ring topology, each devices are connected exactly with the two devices. Like here is the one device, so it is connected with the left side device and right side device. So this is connected with the two devices. Here we are going to discuss about mesh topology. That is the here we will discuss. So let's go. Every computer connected to every other computer. In mesh topology, every computer connected to every other computer. It is like when we imagine about the net, they are connected with each other just like this. In mesh topology, every computer are connected. Every computer are connected to every other computer. First, very reliable. No single point of failure. No single point of failure. There are so many points, and it's a disadvantage is very costly, complex wiring, because we have to connect the computers with all the computers. So it's a very complex wiring. In mesh topology, every network is directly connected to all networks node, all other nodes. In mesh topology, every node is directly connected to all other nodes. Finally, we are going to ending our this live, and but before the ending, we have one more topic, and that's a very small, and we will cover them. Then we will end it, and that's the topic is mode of transmission. I know about mode of transmission things, like mode of transmission tells us how data flow between two devices. That's the normal. Like here we are also transmission the data between users and servers. Mode of transmission tells us how data flow between two devices. Direction of communication. So here we have three directions of communication. First one is a one way. Second one is both way but turn by turn. And when I will stop, you will spoke. That's the things. Both way at same time. Third direction of communication is both way same time, as like we talking on the what mobile phone, like that people they are talking with me, they can also spoke and I can also spoke at the time. That's the thing. So mode of transmission define the direction of data flow between senders and receivers. Flow between senders and receivers. Yes, defines the direction of data flow between senders and receivers. That's okay. And here we have three types of mode of transmission. That is simplex, and second is half duplex, and third is full duplex. And if you want to remember this all the points, so it's a very simple. Like we can remember SHF. S is one way, H is turnwise, F is same time. So here we are going to discuss one by one, and then we will end. Okay. First, when radio broadcast started, oh my god, my internet is going off. That's okay, no problem. When radio broadcast is on, we can only get the listen all the things whatever is broadcasting, but we can't send our response. That's the simplest mode. Like a loudspeaker, you can hear but you can't tell back, talk back, as like simple. So In simplex mode, communication occurs only in one direction. In simplex mode, communication occurs only in one direction. And second one is half duplex mode. Data flow both direction. In the half duplex mode, data flow in both direction, but one at a time. As I said, I will speak and you will stop, and then when you will speak, I will stop. So that's a half duplex mode. Okay, example like a walkie-talkie. When we use the walkie-talkie, so in walkie-talkie, both peoples are both peoples can't talk in the same time. First we'll spoke something, and then second will can spoke. Second will can talk. Whatever. I don't know. Limitations: need to wait for turn. Need to wait for turn. That's a limitation of this communication. It's a very huge limitation. You have to wait for them. As like we are posting the letter by using post. In half duplex mode, data can flow in both directions, but not at the same time. That's a problem, big problem. And here we have full duplex mode, data flow both directions at the same time in a full duplex mode. That's a nice mode we use everywhere in our lives. Data flow both direction in the same time. Example: phone calls, video calls, whatever we can ask and get response at the same time. So its advantage is fast communication, no waiting. Here we have no waiting. You can respond. You don't need to wait. In full duplex mode, data flow in both direction simultaneously. It means in full duplex mode, data flows in both directions simultaneously. That's over. Here are the end of our today's live session, and I know it's very long, but it's beneficial for me, and it will really help me in future. And okay, okay, bye bye. We will meet in next live, and when I have fuck yeah, sit. I have no nothing else.